All right, so continuing our test summaries, we're up to integration. So integration's a short unit and we did it right at the end of term 2. And so we've got only, 4 questions to work through together. All right, so let's start with this one here. In exercise 7a, it's largely a recap of the integration you do in methods. Then we move on to exercise 7b, where we learn integrating to the inverse trig ratios. And so we're presented with a number of formulas, and all we have to do is identify which one it corresponds with and perform the appropriate integral substitution. So here I've got 1 on top of the square root of 4 squared take x squared. So that's going to integrate to arc sine of x on top of 4 and then plus c. Alright, so I'm just looking at my formulas. They're ones that I don't remember off the top of my head yet. So I wouldn't expect you to. That'd be ones that are written down that we can look at and identify. Alright, so that's question 1. On to question 2, and here we have integration by substitution. And the way we can start to identify that, like just in an exam, there's 2 ways. If you're required to use integration by parts, the exam will tell you, it says use integration by parts to show this is true. So that's a big hint. Here, with something like this, if it doesn't say use integration by parts, you either have to use substitution or normal methods. You may have to use parts. It won't always say use parts, but it frequently does. Now what I'm looking at is we've got e to the u, and then I know that sine of x and cos of x are derivatives of one another. So I've got e to the u, I'm looking there, there's a form of du on dx. So that's what we're going to try and do, is express this in terms of u. So firstly, let's go u equals sine of, and I'm always, whenever we have x on 4 or x on top of a number, I always treat it as it's a number times by x. So if that's u, then we can write what du on dx would be, and it would be a quarter of cos of a quarter x. So we have u and du on dx. So then let's restate the integral that we have here in terms of u. So what we have is we have the integral of e to the u. And then this here, all right, if we think about cos of a quarter x, it's equal to 4 lots of du on dx. Okay, so just based off that equation, I can multiply both sides by 4, and we get 4 times du on dx is cos of a quarter of x. So then what we have is we have here 4e to the u, du on dx, dx. The dx's are cancelling. So we have 4e to the u with regards to u. All good? Yep. And so the integral of e to the u is just e to the u. So this is 4e to the u plus c. And we know that u is just sine of x on 4. So it's 4e to the sine of x on 4 plus c. So that's a indefinite integral, so we have plus c. Very good, so that's integration by substitution. Okay, next let's look at the integration by parts, and I'll just write the formula up for integration by parts. So it is the integral of uv dash equals uv take away the integral of u dash v. Alright, so what we have is we've got to identify what's u, what's going to be u dash, what's v, and what's v dash. And remember, we want u to be easy to differentiate and v dash to be easy to integrate. Now, ln x is something that's quite difficult to integrate. You have to use integration by parts to integrate ln x. So that means we're going to put x squared here, because that is quite easy for us to integrate. X squared goes to x to the 3 on top of 3. And so that means our u is ln of x, and u dash would be 1 on top of x. So we've identified all of the components there, and again, this can just be one of trial and error. Like if you're not sure which order they're going to go in, we can do trial and error. Occasionally both will work. So let's sub these into the formula for the integration by parts. We're going to have uv, so we have the integral of x squared ln x is equal to uv, so x to the 3 on 3 ln x, all right, take away, and then the integral of u dash v. So 1 on x times x to the 3 on 3 with regards to x. And now this is something we're just going to simplify and evaluate. That's going to become x squared on 3, and then we'll integrate that. You can think of it like this. Just lastly, simplifying it. Alright. Cool. So then last one, question 4 over the page. Alright, calculate the volume when the function f of x equals x squared is rotated around the y-axis from x is 0 to x is 4. Okay, so let's just have a quick sketch. Integral of y equals x squared. We're going from x is 0 to x is 4, and we're rotating it around the y-axis. Okay, we're rotating it around the y-axis. So, to rotate a function around the y-axis, what we're doing is we're doing the integral from a b of pi times the function of y squared with regards to y. We need the function of y squared. So here we have y equals x squared, so that means x is equal to the square root of y. Okay, and then we need the corresponding y values, because they're the values over which we're integrating it. And so we've got, firstly, when x is 0, the y value is 0. And we're going to have when x is 4, the y value is 16. So this means we're performing the integral from the lower y value to the upper y value of pi multiplied by the function of y, which is the square root of y, squared with regards to y. Now the trickiest part about that is setting it up so that you have all of the parts, and then it's just integration from there. So what have we done? We identified the corresponding y values. Okay, they're the boundaries over which we're integrating it, the lower y value to the upper y value. We found the function of y. Okay, so rather than being a function of x, we're finding the function of y. So rearranging, we're solving for x basically. And then, pi times the function of y squared. So let's evaluate this one. This becomes, the square and square root will cancel. Pi can come out the front. So we're just performing the integral of y with regards to y. And so that's going to be pi times y squared on 2 from 0 to 16. And when we sub 16 in, or when you sub 0 in, that's just going to cancel. So it's just pi times 16 squared on top of 2. And what's 16 squared? 256, 230, 256 is my guess. Yes. 256 on top of 2, so that's 128 pi. And so that's our answer in exact form, and we can convert it to a certain amount of figures. And because it's a volume, it is units cubed. Very good. So I think we're pretty comfortable rotating around the x-axis, like we did a lot of that with our wine glass folio. But yeah, that's how we do it for rotating around the y-axis. So that was a short, sharp unit. Everyone remember